All right, guys. So now we are going to actually get into proving identities and using some of that stuff in the video yesterday. So in terms of identities, here's a couple rules. You're going to have basically equations like this, and we need to prove them. So we want to get the one side to be identical to the other side. Okay, so you're only going to work on one side. You're going to leave one side completely alone. Okay, you want to do your work vertically and show your steps. And generally, you're going to choose the tougher side to work with. So for example, when you look at this, this is the tougher side. So we're going to work with and manipulate that side, and we're going to try and get this side to turn into cotan plus 1. Okay. So first thing we're going to do here is let's distribute this guy in. So cosecant theta, cosine theta, plus cosecant theta, sine theta. Okay. Now, from here, like I said, we're not going to mess with this side. We're just trying to get the left-hand side to turn into that right-hand side. So from here, actually, I'm going to get rid of these. Okay, and notice I have my little chart over here. This is going to be super helpful. So you want to try and do any type of manipulations that you can. So for example, when I look at this, I think, ooh, cosecant times sine is 1. So let's turn that into 1. Okay, and remember, we're trying to get it to be cotan plus 1. So I have the plus 1. Is there any way I could get cosecant times cosine to turn into cotan? Well, you know that cosecant, if you look here, is the same as 1 over sine. So if I turn that into 1 over sine times cosine, then you should say, ooh, this is technically the same as cosine theta over sine theta. And I know from yesterday that cosine over sine is the same thing as cotan. And then I have cotan theta plus 1. Done. Okay, so your goal is to manipulate one side to get it to turn into the other. So let's try this one. So I'm going to mess with the left-hand side again. So from here, let's distribute in. So tan squared theta plus tan squared theta cotan squared theta. Okay, well, ooh, tan and cotan we know from here are 1. Now they're both squared, so it'd be the same idea. If one was squared and one wasn't, that'd be different. So then I have tan squared theta plus 1. And my goal is to get to 1 over cosine squared. So then I say to myself, okay, hold on. Tan squared theta plus 1 is the same as secant squared. And we know secant is equal to 1 over cosine. Now, since it's squared, but that'd be the same as 1 over cosine squared. Done. So once again, I'm just using this chart to plug in equivalent things to get it to turn into this. And they definitely take a little bit of time and a little bit of practice. Right? Now, for example, I did that way. There's another way you could do this, just to show you alternative ways. If you look at the chart and you're like, ooh, 1 plus cotan squared, that's the same as cosecant squared. I'm going to turn this into cosecant squared theta. And then tan, I know that tan is the same as sine over cosine. Now, since it's squared, it would be sine squared over cosine squared. And then hopefully from here, you're like, sine times cosecant is equal to 1. Now, since they're both squared, it would still be 1. And then I'd have 1 over cosine squared. So just showing you alternate ways. They're kind of like a little bit like geometry proofs. There's more than one way to do them. Okay? All right, so this guy, I'm going to mess with the left-hand side again. I'm going to FOIL this out. Now, do not tell me that it is sine squared plus cosine squared. You're taking sine theta minus cosine theta times that whole quantity again. So if you FOIL that all out, just to show you here, you would get sine squared theta minus sine theta cosine theta. Technically, minus, it doesn't matter if you do cosine theta, sine theta. I'm going to do it again. So I'm just going to make that minus 2 because there's 2 of them. Okay, and then plus cosine cosine squared theta. Okay, so from there, let's see what we recognize. Our goal is to get to 1 minus 2 sine theta cosine theta. Well, we have the minus 2 sine theta cosine theta. So what can we do with sine squared plus cosine squared? Ooh, an alarm should go off in your brain. That's equal to 1. So I'm going to replace those two. They don't need to be right beside each other to do that. So I'm just going to replace those with 1 minus 2 sine theta cosine theta. Done. All right, let's try another one. Okay, so here I am. I'm going to work the left-hand side again. And I'm just kind of trying to show you different techniques of things that you could do in these problems. Like I said, there could be more than one route to do. So what I'm going to do here is I'm going to split this up. Okay, now let's be clear. I can split the numerator. If you had a sum of things in the denominator, you can't split that. Okay, so I'm going to split this to sine of beta over cosine of beta plus cosine of beta over cosine of beta. Sorry, I write too big. I know you're supposed to work vertically, but we'll see if it'll fit. Well, sine over cosine, we know that's tan. Oh, cosine over cosine, that's 1. Now, it doesn't matter that I have tan plus 1. It's 1 plus tan, whatever. It doesn't matter. I got there. Done. All right. Let's look at this one, and then we'll do a couple more with working with fractions. So I'm going to work with the left-hand side again. Generally, we work with the left-hand side. Not saying that's like a steadfast rule, but generally that's what I do. So when I look at this one, hopefully you should recognize, okay, I have a sine on top, and that's cosecant on the bottom, which if I look at my little, oh, my screen's frozen. If I look at my little chart up here, cosecant on the bottom, so 1 over cosecant is the same as a normal sine up top, okay? So I'm going to turn this cosecant on the bottom to a sine up top, which would make it sine squared. Same thing here with secant. A secant in the denominator is the same as a cosine up top. So I'm going to turn a cosine up top with that cosine up top would be cosine squared. Now, this one's a little tricky because you're like, how in the world am I going to turn that into that? Sine squared plus cosine squared is 1. Go back up to your chart. Sorry, my screen keeps freezing here. So sine squared plus cosine squared is 1, and we're trying to get secant squared minus tan squared. Well, secant squared minus tan squared is also equal to 1, so I can jump right to that. Done. Okay. Now, these are different types of examples. I'm going to break these into the fraction idea. Let me move down so we can keep seeing it. Oh no. So I got the chart down here. So now this is once again just showing you different methods of how you can manipulate things algebraically. So we could try and create a common denominator. So our common denominator in this would be 1 minus sine theta and 1 plus, excuse me, can't write, sine theta. So this left-hand fraction would need to be multiplied by 1 plus sine theta. Technically on top and bottom, I'm just not writing the bottom. And this one would need to be multiplied by 1 minus sine theta on top and bottom. Okay, so if this 1 is multiplied by that, I have 1 plus sine theta plus that plus sign in the middle. This, when you multiply it by 1, would be 1 minus sine theta. Okay, let's keep going from there. So the sine thetas would cancel, and I'd be left with 2. Okay, that's not from just taking 1 plus 1. Okay, now the bottom, if I FOIL that out, I'm going to get 1 plus sine theta minus sine theta, and then minus sine squared theta. So our end goal is to get 2 secant squared. So let's see, 1 minus sine squared, if you look right here, is the same as cosine squared. And if you have a cosine in the denominator, that's the same as a secant up top. Now the fact that it's squared would mean we would have secant squared up top. Done. Okay, so one technique would be to create a common denominator. And in a common denominator problem, you would always want to show your work for that. All right, let's try another one here. So in this one, I'm going to do a common denominator as well. So our common denominator would be sine theta times cosine theta, each of those pieces. Where this one would need to be multiplied by cosine over cosine technically, and this one would be multiplied by sine over sine technically. So let's distribute that cosine in. So here I would have cosine theta secant theta plus cosine squared theta. Now be very, very careful here with this minus sign. When I multiply this, I'm going to have minus sine theta cosecant theta, but that minus sign needs to distribute to this and this. So this would actually be plus sine squared theta. Okay. from there then, let's see what we can do here. Well, cosine times secant, if you look over here, cosine times secant is 1. Hold on. And then also you have, oh my goodness, you have sine times cosecant. Well, sine times cosecant is 1. So I have 1 minus 1. So those actually cancel each other out. So I'm really left with cosine squared plus sine squared over sine theta cosine theta. Well, cosine squared plus sine squared, we know from our chart is 1. So I have 1 over sine theta cosine theta. And my end goal is secant cosecant. Oh, well, 1 over sine, you can see right here, is cosecant. So I'll turn that part into cosecant. And then a cosine on the bottom is technically the same as a secant up top. Once again, it doesn't matter with the multiplication there, which order they're in. So I'm done. All right, let's do one more. So this one, I'm going to treat like I did that previous one where I split up the numerator. Now, I had said before you can't split up a sum in the denominator, but this isn't a sum. This is a product. So I'm going to split it to tan theta over sine theta cosine theta. Make sure they both get that full denominator. Okay, now let's see what we can do from here. Our goal is to get to secant squared minus cosine squared. So I'm going to rewrite everything in terms of sine and cosine and see what that does for me. Sometimes that's helpful. So tan theta, we know from the side chart, is sine theta over cosine theta. I'm going to leave that denominator alone for right now. And cotan is the same as cosine theta over sine theta. That's in our chart also. Okay, from here then, what I'm going to do is I'm going to multiply by the reciprocal in each fraction. So this is the denominator. So the reciprocal of that, so that's my numerator, the reciprocal of that denominator would be 1 over that. Okay, I'm going to do the same thing over here. This is the denominator, so the reciprocal of that would be 1 over the sine theta cosine. All right, let's see. All right, well, since they're multiplied, those sines canceled, and I have 1 over cosine squared. Those cosines cancel, and I have 1 over sine squared. Ooh, we're getting closer. We have squareds now. Well, 1 over cosine squared is the same as secant squared. And 1 over sine squared is the same as cosecant squared. Done and done. Okay, so I've showed you some different tips and tricks of things that could be helpful in these problems. So just to do a little summary, you might want to distribute things. And then here I did write things in terms of sines and cosines as well to get to my endpoint. Here I distributed it, and once again, using that chart is very helpful to find equivalent things. I showed this 2 different ways. Here, foiling out could be helpful. Once again, I used the chart. Here's the tip or the trick of splitting up your fraction. That could be helpful. Here, I technically got things in terms of sines and cosines again. Creating a common denominator could be helpful. Another common denominator. And then splitting a fraction again. Okay, so these are just some examples to help you along the way. You're going to do some practice of your own. Tomorrow, well, I guess today, once you watch this video, I have optional office hours Tuesday. We'll have our last set of mandatory office hours Thursday and a quiz by the end of the week. Please reach out at any time if you need any help. Thanks, guys.